All right, let's do it. Well, thank you very much for coming to this session. And here we go. My name is Ray. I'm a developer advocate for the Google Cloud Platform. What that means is I try to bring some of the greatest technology that Google has to offer to developers all over the world. And I love to hear about your feedback and your questions as well. So if you have any thoughts or any feedback, please just contact me directly on Twitter at Satanism. All right. And this is a special photo for me. I love to travel. I love to travel all over the world, and I love to take photographs. And this is the desert I went to in China, actually. The long story short, I was trying to find a place to stay as a backpacker in a city, and I couldn't find a place that's reasonably priced. There was no hostels. They don't take any foreigners, so I had to find a new place. And somebody told me, hey, you can actually go to the desert, and if you walk in the desert for 4 hours in southwest direction, you're going to find a real oasis, okay? And you can actually stay in the oasis for free, and that's the oasis. So I know I'm in Morocco. I'm actually going to Mazuga later next week. But how many people here hike in the desert before? No? No one here walked in the desert? Really? Oh man. Anyways, it's like every step that you take, you kind of sink a little bit into the sand. Have you walked around the beach? Walk by the beach, yeah? All right, it's not the same. It's not the same. Yeah. The sand is a little harder. Yeah, so in the desert, every step that you take, you sink a little bit and you have got to pull yourself out. And when somebody tells you you walk in the desert for 4 hours in southwest direction, it does not matter what's in front of you. You just go over it. So all the sand dunes, scorpions, whatever, you just go over it. And it was really hard. And all at the same time, I was thinking, man, this feels like writing a J2EE application 10 years ago. Yeah. Or in this case, writing a very verbose Java application, right? So I have actually learned many different languages. I started with Basic and Quick Basic, and then I started with Visual Basic, where I was going down this basic route. And then I learned the web, and I learned Perl. Anyone here written Perl before? Perl, yeah, it was the language of the web. It was great with string manipulations. And then I picked up Java, and I started with Java J2EE with everything else in Struts, and that was not very fun. But there are many languages I tried. I even wrote I wrote things in Scala as well. The thing about Scala is I know I created something in Scala with this project with Red Hat called InfiniteSpan, and I had no idea what I did. I just wrote the code. I have no idea what happened, and it works, but and Groovy and all that, right? So I tried many languages, and recently I had a chance to try Kotlin. I seen this in the conferences and all that, and actually give it a try, give it a shot. And Kotlin is one of those languages that just felt right, okay? It's got all the niceties that I ever wanted in Java, all the things I ever wanted in Java that I thought we should have, like type inference and name parameters and default values. It's all in Kotlin today, okay? So today's talk, I'm going to just go over a little bit about Kotlin and the basics and why I like it so much, and some of the things I need to watch out for. So some of the things that I found a little weird and you just need to be careful of. And then we're going to see how we can utilize Kotlin and potentially write a web application that will actually be deployed in a serverless environment on Google Cloud Platform in this case, okay? So hopefully by the end of this talk, you feel like, oh yeah, Kotlin is pretty cool, something that you might want to try, and also give the serverless a try as well. So very high level, right? Kotlin was a language that was developed by JetBrains in 2010. It went 1.0 in 2016. And the beauty of Kotlin is that it does not just work with the Java ecosystem with JVM, it's fully interoperable, but you can also compile this down to JavaScript and potentially even native, right? So you can actually write Kotlin native, you can actually compile this down to the native binaries if you want to. But I really like it because it interoperates with Java because we have great ecosystem with all the libraries. But also very importantly, right, just recently we announced Kotlin support in Android. So now you can use Kotlin both for the mobile applications and also for the backend. And that's what we're going to see today. Basically a server-side backend and a front-end that's running on Android that runs with Kotlin as well. So you can have a single language that rules both sides. So let's just take a look. I'm going to just go and show you. How many people here use Kotlin already? Just a few. Okay, so there are many people who hasn't seen it, so I think this is going to fit. And if you see me type something wrong with Kotlin, please let me know. Okay, so I'm going to go into presentation mode here. I'm just going to show you the niceties of Kotlin, and then we're going to go into some of the code that we can actually write for the serverless environment. Okay, so the first thing that you're going to see with Kotlin is that there are no more semicolons, which is kind of nice. So for example, if I want to declare a new method here, I'm going to say greet with a string of name, and I'm going to say system.out.println, and I'm going to say hello, right, and name, and you gotta put a semicolon behind it, right? Now in Kotlin, everything is a little bit more condensed, it's a little bit more concise, which is why I actually like it. So for example here, if I want to declare a method, I just say function or fun, greet, and then the name of the variable, name, and then give it the type, and just like that. And rather than going through system out print line, I can just say hello and name, okay? And as you can see, there's no semicolons. Right? That's really nice. Now, that's just small things, right? Semicolons, no semicolons. You know, I still instinctively type semicolons sometimes, but you don't need to. Now, what is really nice about Kotlin, though, is the fact that it checks vulnerability. What that means is in Java, for this method, you could pass in something like null. And there's no way for you to kind of know about what people are going to pass in. So what do? If you actually have something like, let me go system.out.println, right, name.length, that is going to fail miserably. And then what do we do because of this? We say if name is not null, right? And then you do the checks, and then you try to do things based on conditionals. In Kotlin, this will probably never happen as long as you follow their best practices. What that means is if you say greet and you can say array, that will just work. But if you try to pass in null, this is actually a compile time error. Yeah, this is actually quite nice. What that means is in this function, because this type is just string, what that means is it should never be null. And we can actually check this at the compile time. If you want this to be possibly be null, then you can add a question mark to it, and not just be saying that it may be null or it may not be null, right? And if you want to say print out use the attributes within this, then you can say name.length. Now check this out. Because this is possibly to be null, this dot may actually not work because the name could be null. So again, it fails at the compilation time. This is really nice, right? But if you remove the question mark, then this check went away because this will never be null. Now, if you actually want to deal with this possibly null scenario and you don't want to write the if name is not null such and such, what you can do is just to say question mark dot. Okay. What that means is the name could be null, but if it is null, then this whole expression will return null. Okay. And we can actually run this. Let me go ahead and just make sure I'm not cheating here. I'm going to run this app. And we should be able to see something like, oh, there we go. The first one, the whole thing is null. Rather than getting a null pointer exception, I just see the null point, that you just print out null, right? It's pretty nice. It's kind of convenient. So with Kotlin, again, in Java, you gotta deal with the optionals and maybe use the GSR annotations. But here, we just deal with the language directly. Now, another thing here that you're going to see is in Kotlin, and the reason I mentioned Perl is because in Perl, we can deal with printing out variables directly within the string. So rather than putting a add name and construct your string with additions and all that, you can just put a variable like that, just like Perl. You can have the $ in the variable name, and now you're printing directly into the string. So if I say hello Ray, and this would just work, right? It's one of those niceties that people don't, kind of appreciate first, but when you do more and more of these, it's actually quite convenient. And in addition to this, if you actually need to print out multiple lines, what do you do in Java? We add it up. We have like something like system.out .println. Right, and then you say hello, and then you do that, and then you have add like welcome to DevOps Morocco, right? And then you do a print line again, and such and such. You just keep on adding these things. In Kotlin, what they have done really, really nicely is it gives you something that other languages have, which is multi-line strings. So in Python, they have it. In some of the other languages, they have it as well. But here, we can just say, like with the three things, the three quotation marks. I can say, hello, Ray, or something. Welcome to DevOps Morocco. And now that's a multi-line string. Okay? It's very, very convenient. Now, one of the things I really do like about Kotlin, in addition to mutability, is the fact that in Java, if we want to write a class that simply holds values, like a data class, like which is properties and stuff like that, what do? Well, we gotta deal with a POJO. How do you deal with the POJO? I'm gonna do something with color, right? I'm going to say public class color, and maybe I have a short. Let's go red. Red color is three different colors. I can say, let me see here, private short, green, RGB, right, and blue. I keep on spell this incorrectly, right? And then if you want to make it immutable, you gotta add final, right? So that once you construct this object, you cannot change the value anymore. But of course, this doesn't work just like that. You actually have to initialize the constructors, right? You have to add the constructor parameters, so you gotta do that. But then you cannot access it because you need to add the setters and getters, so you gotta go and you gotta generate the getter and setters, so you gotta do that. And then, of course, that's not enough. You may actually need to implement the equals and the hashes. And what do? You go back to the IDE, you generate the equals and hashes, right? And you do that. And then maybe you want a toString, and what do? You go and generate the toString. And you might be saying, well, that is not too bad, right? The IDE is doing all of these things for me. But the problem with this approach potentially is, well, what if you add a new field? Like now you want to have a name. Now you have to go back and regenerate everything, right? Which is kind of annoying. In Kotlin, it's really nice. I wish I discovered this a little earlier. In Kotlin, all you need to do is to declare a data class. And you can say color. And within this data class, you can just say, okay, I want this to be read-only, so you cannot assign any values after you construct it. Then you can use the keyword called val, which is a lot more condensed and final. You should use this by default all the time. And you can just say red is, there you go. You can just say red is short, right? And you can say green is short as well. And you can say blue is also short. Now, the other thing you're going to see here is that there's no primitive types. Rather than having the difference between short with a capital S and small s, it's just capital S all the way because they only have objects. Behind the scenes, because this value cannot be null, they will map it to the primitive for you. But as far as you're concerned within Kotlin, there's no primitives. There are just objects. Okay? And now you can actually go back and you can construct this object pretty easily. I can say color, something like val red is equal to color and 255, 0, and 0. That will make a red color. Okay? Another thing I really like about Kotlin, there's so many things I like about it, because these are the things that we're asking for in Java for a long time. One of the things that is really nice is the fact that you can actually use name parameters. What that means is when you want to create an object, rather than rather than passing all of these values in order, you can say green goes in first. I'm going to say green is equal to 255, and red is 0, and blue is equal to 0. Right? And that will construct the green, which is quite easy. Now, what is even more is you can also assign default values. What that means is if you have like overloading, in the past what we need to do is, well, what if we want to default green and blue? Well, we create a new constructor with red, and then in the constructor we say green and blue is equal to 0. Well, here you can just say, by default, if you don't pass anything, assign 0 to the value. And just like that. What that means is rather than passing all these red and blue behind the parameters, I can just simply remove it. And now the other, like the blue and the red is now 0, and we only assign green. And we can also just print it out. So I can just say print green. It implements the equals and hashes and also toString for you behind the scenes automatically. So if I were to run this again, let me see here. I'm going to just run. And if I scroll up, there you go. you can see that green is 255 for the color, and the red and the blue is 0. Okay, it's really, really simple to use. In addition to this, I'm just going to touch on a few other things because these are some of the basics, what I'm going to show later, is that in Java, the only way that you can extend, add functionality to a class is by extending it, right? But then if the class is final, then you cannot extend it anymore, okay? The other thing is whenever you override it, when you extend something, you have to maintain the behavior, right? It's very easy in Java for you to extend something and screw up the behavior because it may not be intended. Now in Kotlin, extension is explicit. What that means is you have to write your application to be extended. You actually have to declare something that's extendable. What that means is I should be able to say something like, I'm going to create a new class called, I don't know, vehicles. So just things that drives on the road, right? And in this extension, I'm going to have a var called wheels. And maybe, var wheels is of int, for example. Can I do that? No, yeah. And initializer is 0, yeah, so I can do that. And then I can have a function called drive. And in here, I can say print line driving my vehicle with wheels or something like that, right? If you want to extend this, for example, if you want to extend it and say you want to make a motorcycle, then you say class motorcycle and then you extend it like that. And that's going to tell you it fails. Because the classes and all the functions are final by default. This is one of the design decisions that they made in Kotlin because of the possibilities of people screwing up when they try to extend it. So if you want to really extend some functionality with a class, you can just say, you have to say open to make it non-final, right? Now you can actually say it, and oh, there you go. Now you can actually extend this thing. Now if you want to override drive, right, you can say drive, and then I'm going to say print line, riding my vehicle. And this is also going to fail because you gotta, well, first of all, you gotta override. You have to use the override keyword, and then you also have to open it. That's one way for you to extend functionality. However, there's something even better because in some cases, you just want to add a functionality to a class or to an object that you don't have control over. Okay? So you can actually write a function that's called an extension. So what that means is I can declare a function that operates on a string, and maybe I call this translate, right? I can just do that, and now I can, do my magic of translating the string to a language, right? For example, I'm going to pass in the languages here, like string, and then maybe I just, for the purpose of this talk, I'm just going to say return the language, right? And I need to add a return value. What this does is now, anytime that you use a string, you get this translate functionality, right? So if I go back to here, I say print line, and I'm gonna say Ray, and I translate. Now you can see there's a method here called translate, and I can say translate to, I don't know, French. Yeah, there you go. And that will just work. You can actually add more functionalities to your classes, yeah?
Does this class has to be open? For example, the string class?
In this case, no, actually. You can just add extension functions to just about anything. Yeah, yeah. But and the way you refer to the current one is by using this as well. Now, what is even cooler is if you want to say implement a operation. Okay, so if you want to implement additions, subtractions with numbers, or in this case maybe with colors, maybe I want to mix two colors together. So what is red plus green? What color does that make? Yellow? Is that right? I don't know. So I'm going to say yellow is equal to the red plus green. I don't know if that's the case. I'm just making this up. And you can see that, whoa, this plus is red because you cannot just add two objects together in Java, for example. But now in Kotlin, you actually can. All you need to do is to define an extension function that implements the operation overload. So you can say operator font, okay, color dot plus, and then you can say the right-hand side is also a color, and you're going to return a color back. Okay? Now what you can do is you can say return a new color that adds this color, and you can say this dot red with the right dot red. Okay, that's the first one. And then you can say the green plus the right dot green, and then you can say this dot blue plus the right dot blue, right? So you can potentially just use some of these things. So yeah, but the problem is because I'm using a short, and when you add two shorts together, it makes an int, and that's why this doesn't go through. But once this is declared, this plus will just go through. Now, if I really want to do this, I will go back here, and I can just change the type, right? So I can say, oh, what happened here? Int, and int, and int, right? And imagine if you're doing this in Java, you have to go and modify all of this code. In Kotlin, you just modify this one line, and now this add operation is done, and I can just show you what that looks like, yellow, right? And I can just go and run this. This is quite neat, right? And there you go. Oh, wait, did I now add this together? Yellow, green, green, green. Oh yeah, I added red here, so there's I need unit test in this case. Right, so I can do that. Now I saw something here. You can actually declare a function, I think with a string. So you can say test my color, right? You can actually do that, and that becomes a function, right? That is pretty cool, right? So there are some people who are writing unit tests basically by being explicit about what they are testing, and you can have a whole sentence in here. Yeah, it's pretty nice, right? Yeah. All right. The last thing I want to talk about is the Java docs, right? In Java, you have Java docs, and the thing that you do when you want to reference to code, you might do something like this is a class, right? So you gotta say what is this code, right? That makes this a code block or like a prefix. And then if you want to refer to something, you say C link. Sorry, the other way. C link string, right? It's very verbose, but I cannot blame them. This was from the 90s. Now we have things like Markdown and things that makes it easier. So in Kotlin, you can also use something like this is a class. So that will become just a code block. And you can also do something like C string. And rather than using the link with the annotation, you just use the square brackets. Very, very cool. There are some things that you do have to watch out for, though. For example, in Java, if you declare a class, if you don't put in the public, what is the default visibility? Package, exactly. In Kotlin, everything is public by default. So all of these things I declared, they're all public, which is something you have to watch out for. You really have to go back and say, what is not public? This is one of the things that kind of annoys me, because they got the extension right. You have to be explicit about what you can extend, but everything's public. So you gotta go back and just make sure things you don't want to expose is not public, right? The other thing that annoys me just a little bit is the fact that there's no ternary operator. So what that means is, like, you can say string name is equal to, like, A is equal to greater than B, and if it is, then it's Ray. If not, then it's somebody else, right? Like, say Baruch, my friend here, right? So this is a ternary operator. In Kotlin, because if statement is actually an expression, so they don't have a ternary operator. What they have is just say name is equal to A. So you say if A is greater than B, right? Then you do something, and then else, blah, 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 right? So that's how you deal with Kotlin. You actually have to write it out. The last thing that could be really annoying, that you just have to really be careful, is the fact that because you can extend anything from anywhere, right? You might not know what all the possible calls you can make on a class. And you can declare all these functions and classes outside of the file with the same name. Now you could actually have things everywhere, right? So what that means is you really need to be careful about how you organize your code. It's just like Scala in Perl. You gotta be very mindful of how you organize. And in the end of the day, you really just might need an IDE to help you write these code, right? It's very convenient, but imagine if I don't know somebody declared the translate function. Well, how am I going to know, right? Where do you even find this? You gotta have an IDE to kind of see what's going on, all right? So that's a very basic introduction of the Kotlin language. There are a lot more. So what I'm going to show next is really just how we can utilize it. And so here we have an Android client, and then here we have a Java application, okay? And you can use Kotlin with any framework that you want, literally, right? So let me just turn this off a little bit. I'm gonna get out of the presentation mode because I don't need this anymore. I'm gonna close it, okay? So here in the code, right, we can write a Spring application. You can generate Spring Boot application very easily, and you can actually just use Kotlin as the base language. They have some nice things that they built into it, and you can just go ahead and create the controller. You can use all the annotations, of course, and you can also use the niceties of the language. Now, what I'm going to show, though, is how you can actually deploy this into a serverless environment. That will be the second part of my talk, which is potentially using something like App Engine. I don't know if anyone knows App Engine here. It is a platform as a service from Google Cloud. In this case, it's completely serverless. If you want to argue, right, this could possibly be one of the first serverless platforms in the world since 2009. Why is it serverless? What do you think about when you think about serverless? You think about, well, you don't manage your own server. It should be able to spin up very quickly, and you pay for what you use, right? So what that means is you don't want to keep two servers running continuously to run your Kotlin web application. Well, in App Engine, when you deploy, unless if somebody uses it, there will be 0 instances, and you don't get charged for it. If somebody wants to use your app, we'll spin up your application on demand, and we charge you for the amount of time that the application is actually running. Okay, so that effectively makes it serverless, and there's nothing you have to manage. Okay, and on top of that, you can also use all of the Google Cloud APIs, which are managed services. Again, you don't have to manage your backends. So, for example, you don't know what type of application load you're going to get. Every application is going to be slightly different. So with App Engine, you basically you can deal with all of these different variations of load. Will scale out for you on demand, regardless of the type of load that you have. Okay. In addition to this, one of the things that people don't really think about serverless is where is the real bottleneck when it comes to scalability? What is the real bottleneck? It is not your service, right? It's not the API that you're writing. It is not the functions you're serving. The real bottlenecks always goes into the database, right? If you have a single MySQL database, you can only handle so many function calls. You're gonna be stuck somewhere, and then you have to deal with things like NoSQL and MongoDB and other things potentially, or you have to deal with the complicated MySQL architecture. With App Engine, because it was designed for scalability, we also offer services that scales behind the scenes, like the data storage. So the database that you can use in App Engine, you have multiple choices. You can use SQL, of course, but if you want true scalability, you can use something like data store. And this is our NoSQL store. The underlying technology is the same technology that runs Gmail. Okay. And also, I believe anyone here play Pokemon Go? Anyone? Pokemon Go? It was very popular. It uses data store behind the scenes as well. Now, we actually handle, the last time I checked, like a year ago, we handle about 15 trillion transactions per month. That's how much data is going through the data store. And the beauty of it is you don't have to manage anything. Okay? There's no database you have to manage. There's no service you have to think about. In addition to that, we have tons of APIs you can call, like machine learning APIs. You can recognize pictures, you can recognize text and speech. App Engine was started in 2009 with Java, but now we can actually run Java 8 applications. You might be saying, well, why did it take so long? I thought we were on Java 9 already, right? Why are we still running on Java 8? Well, the thing is security. At Google, we really take security into our hearts, and this is very, very important to us. Basically, we are required to have multiple layers, at least one layer of security for your untrusted code. We need more, right? We need multiple layers to run your code in our infrastructure so that you cannot, hack other people's systems, right? So because of this security constraint, how it was implemented in the past was directly implemented within the JVM using a JVM security manager, okay? And so when the new JVM comes around, we have to, recheck these security rules and apply the new rules. And that takes a long time for us to enforce and know what we need to check because we actually have to check it within the JVM. And because of that, App Engine in the past is very restrictive. But now, you can run anything you want that runs in Java 8. There's no more restrictions. There's no more sandboxing in terms of like in the JVM level. We sandbox around the JVM. So we still are secure. We can still have multiple layers of security, but it is just applied outside of the JVM now, okay? And what that means is you can really run just about anything you want. You can run native code. You can use JNI. You can use all of the popular frameworks like Spring Boot. I personally make sure that Spring Boot actually works with App Engine as well. You can also use JHipster and a bunch of other things as well. And of course, because of this new sandbox, because we don't have any more restrictions, you can also use Kotlin in App Engine as well. So if I go back to my application, this is a Spring Boot application with a REST controller that has a counter that just counts how many people hit this URL. We also have a greeting that says hello to you. I think it's actually here with the greeting and the lookup, right? And whoever wrote this, I didn't write this code, my colleague did, right? They also took advantage of the multi-line strings and also the string templates to return some values, okay? Now, to turn this into an App Engine code, well, first of all, you do need to make this a war file. This has to be a war package, okay? So if I go and look for packaging, oh, no, I don't want to change it. Packaging, there we go. It does need to be a war. That is because in App Engine, we will spin up a JT application server for you behind the scenes, and we optimize it so the JT server can start in like a second, and then we start your application immediately after that. So the whole time, the time that it takes to start your application is really how long your app takes to initialize, okay? So this has to be a war file, and we do something like you need a serverless API. Some of the things that's basic to a war you do need, but this should be just scope to runtime. And then if you want to deploy something to App Engine, you just add not that one, sorry, that's not the one, this one. You add the App Engine Maven plugin, okay? And if you do add this plugin, what that means is we can actually start the entire simulated environment for you to test your code before you deploy. And then you can use this plugin to do the actual deployment. So, for example, if I want to run this application, typically what you do is you say Maven Spring Boot, not Rob, run, right? Yeah, and you can run this Spring Boot application. But if you want to run this in an App Engine simulated environment, you can just do App Engine run. And what that is going to start the application server for you. It's going to deploy the application. But in addition, it also starts the emulators, right? Because if you want to test against the data store, if you want to test against some of our APIs, well, you don't want to make a call out to the external internet. You can just test everything locally here. So for example, I deploy this, and so let me go and see if this works. I'm going to say local 8080. I'm going to say lookup array. I think that's one of the methods. Oh, is it not one of the methods? Let me just make sure. Sometimes I have multiple Java applications running. Let me just make sure that's not the case. Great Java. Yeah, I think there are multiple Java running here. So I'm going to kill, is that a good idea if I kill OJava? Yeah? IntelliJ will die? I don't know, that's fine. I'm gonna kill OJava. Oh, I'm still good, all right. As you can see, I'm not running Eclipse, so this actually works. Yeah. Eclipse, I think that wouldn't work so well. Okay, so I just want to make sure there's nothing else listening. And let me go ahead and try this again. And I'm going to do this increment counter, right? So I should be able to say localhost. I should be in the Spring Boot application. There we go, increment counter, right? So you can see on the top, whenever I refresh, I'm incrementing the counter, but this is actually operating against the data store that is in the emulator. Okay, and I can actually see this emulator by going to the admin console that's running locally, right? So you can actually test out all the things that you need to use. I can see my counter, and that's the current count. Okay. Now the way that we wrote this code is also pretty neat. So if I go back to the code and I see the increment counter, right? First of all, in data store, it's a NoSQL data store. What that means is you have to, everything that you store has to have a unique key. And it's a document database. What that means is you can add whatever field that you want. Okay? So in this case, what I'm going to do is I'm going to create a key for my counter. So I'm referring to the same counter all the time. So I create a counter key, right? And then I need to grab the data store service so I can store data in it. Now here's where Kotlin comes in. That makes it a little bit better. In the data store service, there's a get and set method. Okay, so if I actually want to see get, how do I do that? Like the data store. So here's the thing about Kotlin. When you assign a variable like that, you actually don't know what class that is, right? And when you use it again later, you're like, oh, what is that class? Oh, I gotta go here. What is that class? I need to know what this returns, right? So you gotta be careful with that. But because data store actually service has a getter and setter, you can use the syntactic sugar with just a square bracket, and that would just call put in this case, or get. In this case, it would be get. Now, because this is an expression, not just a statement, not just a control, because this is an expression, what this is trying to do is to get the entry from data store with a syntactic sugar, and then if it's there, set it to this variable. If it's not there, because this is an expression, I can cache it, and then I can initialize. When I initialize, I can create a new entity. Okay. Now again, this entity actually does not have a get by default, right? So when you want to set something in the entity, you usually call set property like that. Now, because if you have to type set properties all the time, you cannot actually use this expression. So what do? You can actually use the extension functions, right? You can also say, I want to add get and set to the entity class and map it to get property and set property. And as soon as you do that, you can go back to the code. Now you can actually just set the field like an associative array, just like a map, right? So this is really neat. So I can say new entity. I can give it another field like person is equal to Ray, right? Like I can do that too. This is pretty easy to do, okay? Now the final thing is transactions. Data store deals with transactions, but you do need to write transaction blocks. What that means is you actually have to grab a new transaction, you got code begin, and then when you want to commit, when there's no arrow, you say transaction commit, or you say transaction rollback. Okay. Now in Kotlin, what you can do, this is super, super awesome, is you can actually write another function that taking a block of code as the argument, right? This is almost like a lambda, but they call this a code block, right? And so you can actually write a transaction block, a transaction extension function, okay, for data store, just like that. So you can say data store service, I want to add a new transactional functions here, and you pass in the block, okay? And so what that's going to do is you can pass in any code that you want. If the code actually succeeded, it's going to set OK to true, and then that will generate the commit, right, for your transaction. If something gets thrown, well, OK would not be true, then this can be rollback, right? So now you can actually write your code here in a single transaction block, right? So for example, in this block, if I say throw new, I don't say throw new anymore. I say throw exception, exception, except if I can spell. If I throw exception, well, or if I put it here, this block will roll back. Yeah? All of these things are being done directly through the Kotlin language. Now you can actually write very nice readable code. Now, with that being said, once you test your code locally, then what you can do is to deploy it, right? So now we do have the App Engine plugin. So rather than using App Engine run, when you're ready to deploy to your serverless environment, you just say App Engine deploy. Deploy like that. Now, this is actually going through my phone because the internet is questionable here. So I don't know how long this is going to take. It will actually upload my GSPs if you have GSPs. It's going to upload my WAR file, right? And at the end of it, there we go. It's uploading 4 files now. Oh, it's done through my phone. That's amazing. It's a WAR file. There's very little dependencies apparently, right? And it also does the diff. So if there's something on the server already, it doesn't actually resend the whole thing. So it only potentially sending the differences. So right now this is deploying. It is actually potentially not spinning up anything. If you set the default minimum instance to 0, it would just be 0. But this is done. Yeah, I just deployed into my App Engine environment, a regular Java application, in this case a Kotlin application. And hopefully I would just be able to go there. And what was the thing I called? Increment counter, is that right? Increment counter? Okay. And the first load may be a little slow because it's actually going to start your application on the first load, right? So if you make your application start faster, it will start faster too, right? Also, this is going over my phone, so we're gonna see if this comes up. Oh, there we go. So now this come up. This definitely latency in my phone, right? And I can just see this application running. And I didn't do anything. And this application can be scaled out to hundreds or thousands of instances because I don't have a bottleneck in the data store either. Okay? So the last thing I want to show you, let me just double check the other endpoint works. So I think there's an endpoint called lookup, and I'm going to say Ray. Let me see if that works. No, it's not lookup. What is it called? Where is it? Let me see here. What did they say here? It's the request param. Okay, so what it is doing is you gotta do lookup, and name is equal to Ray. There we go. That works. Yeah. So hello Ray, you executed the handler. So now I think I only have 3 minutes left. I think I'm gonna go to Android Studio, and again, like I said, Kotlin is fully supporting Android now, right? So rather than dealing with Java 7. You can just use all the niceties that I talk about with Kotlin. And in addition to the syntax sugars that you get, the real beauty is this. I don't know if anyone here writes the Android application, but every time you need to refer to a field, like an editor text field, you have to do this. You gotta say find view by ID. And you have to do the cast, right? Because you don't know what this is. You have to cast it to the right type. And then once you have this, you can say name input, and you can set the action listener. Then you can actually do things, right? In Kotlin, what they have done really, really nicely is it automatically generates these imports for you. So now the input field is just another type, right? And if it's just another type, you can just say name input dot, and then you can just set the action that you want to run and run the action. As you can see, you don't have to use find by ID anymore. This is really, really awesome. So what this will do is to basically make a call. It's a very simple app that is going to make a call out to my application I just deployed. And again, this is a read text, so this is a nice extension function that they added within Kotlin. But again, like if you look at the code only at URL, you don't know what this is unless you refer back to where it's declared with the type. Then with the IDE, you actually know there's an extension function you can use. So let me just run this real quickly. I'm going to start my emulator to run this application. Okay. And I remember my very first Google interview in person with a developer advocate of Android. He asked me, Ray, I see you actually wrote application for Android and iOS before. Which one do you like more? And I told him, look, like I really like iOS more. And he's like, why? Well, because the emulator in Android takes forever to start. Well, they fixed it, as you can see. After a few years, they fixed it. Now you can actually start your real emulator. This is not simulator, this is emulator. You can actually run your emulator really quickly, and hopefully I can say Ray, and it just made the code out to the internet and went to my serverless application without any things I have to manage. One of the things I found recently on Twitter, I think it's called, let me just find it for you. No. I'll wait for that to finish. I'll finish real quickly. Okay. So one of the things I found on Twitter is this company called Rio3KS. It's got a fascinating blog if my internet works. Oh, come on now. Rio3KS and App Engine. They wrote a really, really nice blog on Medium. Let me see if I can find the Medium post here, because it's a little slow, and I'll be done in a second. Come on. No? No, I guess it's not searchable yet. But anyways, this company, they have about 200 App Engine projects in production that they write for their own and their customer, and they have 0 ops. They don't have a full-time DevOps to handle all of their backend applications, which is super, super awesome. We have tons of case studies of people doing this, and it is one of the, now I can safely say this is one of the coolest products that we have seen so far. Because in the past, with all the restrictions, you don't get to run Spring and Spring Boot easily, but now you can just basically run whatever you want. Okay? So with all that said, I think my time is up. So thank you very much for your time. You can find more information on the links. All right? Thank you. Yeah, and I think that there's a next speaker, or no, there's no next session. So any questions that you guys have about App Engine or Java or whatever?
What's the memory footprint for the Kotlin?
For the Kotlin application, yeah. I actually don't have the number for it. But there are really interesting studies which I encourage you to read. There was one study by Pinterest. So apparently Pinterest uses Kotlin a lot as well. And they actually have a performance comparison between Kotlin and Java. And what was the most surprising to me is that not only do they perform up to par in terms of performance, in some cases it was actually faster in Kotlin. So my internet is really slow right now, but if you do the search for Kotlin Java performance, you're gonna find the blog from Pinterest. Yeah. Okay.
And the IDE support is limited to IntelliJ, or there are?
So IDE support, I think it's obviously the best IntelliJ because it came from the same company. Like I said, like if you want to deal with the extension functions, you need to know what can be used. You kind of need an IDE for it. I have to agree. Yeah, unless you remember and you go back to the doc all the time. Yeah, yeah. Okay. Yeah. So, well, thank you for your time, and give it a try, and give App Engine a try. Yeah. Yeah. Thank you.